just wait for a few more minutes and see if someone joins and then begin? So let's begin. Hello everyone, this is Tanya. I'm one of the TAs assigned to the Aircraft Attain Control course. Now we'll go over the contents questions of week 5 and then some questions from week 6 to help you with the assignment. So we'll start with the assignment questions of week 5. Before that, just some recap of all the formulae and the concepts that we've studied in week 5. So a delta E trim is the amount of elevator deflection required to trim the aircraft at given CL trim. Alright, so we have gone over this equation before. We had seen this when we introduced controls, right? So the stability or the equilibrium condition that we studied, this trim condition, was cruise. At cruise, we have lift equal to weight and thrust equal to drag. So this was the condition at trim or at cruise that we had studied. So now some other maneuvers were discussed during the course. So steady climb and landing were discussed. During steady climb, our equations of motion change, our force equilibrium changes. So for this cruise, we had thrust equal to drag, lift equal to weight. In the case of steady climb, we have an angle introduced. So the fuselage reference line is flying at an angle. So we have something like this. So this is your x-axis, y-axis. Your thrust is now inclined with an angle, comma, this is thrust, this is drag, your lift is perpendicular to this, that's lift, and weight remains acting downwards. Now when you resolve these forces and derive the equations, we get T minus D minus W sine gamma equal to 0 and lift equal to W cos gamma. Alright, so what happens here is like our load factor for cruise was, load factor is lift upon weight. So this was 1, load factor is 1. Now for steady climb and other maneuvers, it will not be 1 because lift is not equal to weight, lift is equal to W cos gamma. Right? So your load factor changes. Similarly for landing, the thrust is inclined in the other direction at an angle gamma. So the equations that we get, and then the coefficient of lift is given by this formula. Now while landing, due to ground effect, what is ground effect? The reaction force by action of the air on the ground, it changes the effective angle of attack at the tail. Right? So delta alpha tail is what is given there due to it's something similar to downwash. The ground effect is something similar to downwash. What is the effect? The delta alpha tail, or the change in effective angle of attack at the tail, is epsilon by 2, and epsilon formula we know. Alright. Now to counteract this, so due to this change in angle of attack, there is a nose down moment. To counteract that, we need to deflect the elevator by some amount. That delta E is given by this last formula. Now, two conditions that we had studied in the aircraft performance course was minimum thrust required, and maximum power available. Right? So for minimum thrust required, we know that the lift drag is maximum, L by D ratio is maximum, and for these conditions the CL value is under root of CD naught by Q. Now for the maximum power available, what is it? Rate of climb. R by C is rate of climb. Rate of climb is max. When you go through the equations, you remember that the TV minus dV by W is V sine gamma, that is rate of climb. R by C is rate of climb. TV minus dV is nothing but power available minus power required. Alright, so power available minus power required by W is V sine gamma, and that is the rate of climb. So these are the two conditions that we studied in aircraft performance, which will be used for your maneuvers. Alright. So the two maneuvers that we have seen in this lecture So two maneuvers that we've seen are pull up and steady coordinated turn. For pull up, unlike the cruise, lift is not equal to weight, lift is greater than weight. So your load factor becomes L upon W and it's greater than 1. So this is greater than 1. But for your climb, it was equal to 1 because lift is, for your cruise, it was equal to 1 because lift is equal to weight. Now when you write these equations, you can see that you find the pitch rate. Pitch rate for pull-up maneuver, pitch rate is given by Q, is derived as G upon V into N minus 1. Okay, So this derivation was dealt with in the class. So pitch rate for a pull-up maneuver is given by this formula. And pitch rate for steady coordinated turn is given by this formula. Now for steady coordinated turn, again L is not equal to W. So there is an angle by which it is turned in the same level. So that is given by phi. So L cos phi is W. Again load factor is L upon W, which is not equal to 1 as in the case of cruise. So here load factor will be greater than 1 or less than 1. Will the load factor be for steady coordinated turn? Will it be greater than or less than 1, or it's not equal to 1? What would it be? Look it up and I'll get back to it next class. Look it up and tell me what do you gather from it. So pull up we have seen that it is greater than 1. What about steady coordinated turn? We'll just look it up and let me know in the next class. Okay, so the pitch rate for steady coordinated turn is derived as G upon V into N minus 1 by N. Now the delta E required to trim the aircraft we had seen, it is this formula. Now due to these maneuvers, you will have an additional delta E requirement. So delta E trim plus this delta E will be required to trim the aircraft during these maneuvers. Alright, so that is given by, it's an approximation, minus 1.1 Q LT by tau V. That 1.1 is an approximation, it's an empirical relation. So Q is plug in for whichever maneuver the aircraft is performing, either pull up or steady coordinated turn. So just plug it in and you find the additional delta E, additional deflection of elevator during the maneuvers. So you get that using, and LT is just the momentum. Alright. So let's go to the questions. The first question was for steady coordinated, it hasn't loaded. Okay. For steady coordinated turn, pitch rate Q is given by, it's a direct question. We have just seen the formula. Direct formula. What is the answer? Third option, yes. So Q for steady coordinated turn is G upon V N minus 1 upon N. Correct. Next question, for steady climb, which of the following is correct? CL climb is greater than CL cruise, is equal to CL cruise, is less than CL cruise, none of this. So for cruise, lift equal to weight, and for climb, lift equal to W cos of gamma. Cos gamma, right? So what would be CL? CL formula, what was lift? Lift is half rho V square S CL. So your CL cruise would be 2W by rho V square S. Here it would be 2W cos, this is CL, 2W cos gamma by rho V square S. So what is the right option? CL climb was less than CL cruise. Next, data for question 3 to 4 is given below. So you have VH. VH is horizontal volume ratio, ST upon S, LT upon C bar. Tail efficiency factor, What was tail efficiency factor? Why did that come into play? What is the formula for tail efficiency factor? So it was the ratio between the dynamic pressure at the tail and the free stream. So it was Vt square by V infinity square. If you know tau, they give you Cl alpha tail. Okay. Find the value of Cm delta E per radian. So it's a direct substitution of the formula. Put it up. So the formula is Cm delta E is minus eta VH Cl alpha tail tau. So that's minus 0.85 into VH is 0.54 into Cl alpha tail is 4.434 0.48 0.41. So how much is this value? What is the delta E required to trim the aircraft with static margin 10% given that the CL trim, at what CL we want to trim the aircraft? It is 0.31 and delta E naught is 0.049 radian. So again direct substitute the formula. So delta E required is delta E naught minus is static margin Cm by dCl delta E into CL trim. So delta E naught is 0.049 minus dCm by dCl is minus of 0.1 by Cm delta E is minus 0.834 and CL trim is 0.31. Answer B. And do let me know if I'm making a mistake somewhere. What would the answer be? Try calculating this. 0.011. So I think the closest option is 0.012. Okay, let's go to the next question. So this was the formula that we used. A maneuvering point is defined as the CG location where d delta E by dCl is 0, d delta E by dN is 0, d delta E by dCm is 0, or d delta E by dCd is 0. This is just by definition. So d delta E by dCn is how maneuvering point is defined. So the other points that we had were CP, AC, and neutral point. How do we define all of this? CP, what is CP? CP is center of pressure. How is it defined? Okay, what about AC, aerodynamic center? Correct. So pitching moment is independent of angle of attack. What about neutral point? So AC and neutral point are similar, exact same definitions. AC is for aerodynamic surfaces like wing, elevator, canards. Neutral point is for the entire aircraft. Yeah, so these two are analogous to each other. CP, center of pressure, is the point at which the aerodynamic forces are actually acting, lift and drag. Since this point keeps changing across the flight profile, we have chosen AC to be the point that's constant with angle of attack. CP keeps changing with angle of attack, and so it becomes difficult to perform the analysis. So we move the forces from CP to AC. That's why it comes with a moment. So the lift and drag and a pitching moment. So that is how CP is defined. Next, in a flight test, the following data was obtained while trimming an airplane at different speeds. So they've given you angle of attack, CL trim, how much elevator was required to trim the aircraft at the given CL trim, and what was the CG location. So they've flown it for two different CG conditions at different speeds and a different CL, and trimmed it at different CLs. The lift curve slope is 0.1 per degree lift curve slope of aircraft. First question is, what is the value of stick fixed neutral point? So how do we do this? So we use this equation, delta E trim, because we have delta E trim values are there. We don't have delta E naught. We need to find out X and P. We don't have that. We have this CM delta E. We don't have CL trim. We have. So you have four equations. You can find. You have 4 points. So you have four equations and three unknowns. So you will be able to solve it. Solving simultaneously in the equations. I'll just show the way that I used, but you can use any method to solve the three or four sets of equations to get the three variables. We just need to find out one of those variables, X and P. So what I used, it need not be the easiest way, so this is just something that I used. I took each of those points. Before that, so when I say elevator deflection up, so when I say 3 degrees up, is it positive or negative according to our sign convention? Degrees up, elevator deflection. Sorry. Is it okay? But our convention was deflection of elevator down is positive, so this is negative. So this will be -3. This is +1. This is 0. And this is +1.5. Alright. So now I'll just write down the four equations that we have. So first one would be delta E trim is -3 equals delta E naught plus x bar into minus x bar CG is 132. C delta E we do not have. CL trim is 0.54. Similarly, next one is 1 equals delta E naught plus x bar into minus 0.32 CM delta E into 0.35. Alright, so I'll just subtract these equations. What do I get? Minus 4 equals x bar into minus 0.32. So this is common. C delta E, and here you have 0.54 minus 0.35. So I'll just write the equation in terms of Cm delta E. So we have Cm delta E is so I made the equation in terms of Cm delta E x and P. Just keep this here and use the other two sets of equations, other two variables. So here we have, I'm using this and this. We have 0 equals delta E naught plus x bar P minus 0.44 Cm delta E. again write the equation in terms of Cm delta E. So it's Cm delta E is minus 29 by 1.5 into x bar NP. Just split the screen. Can you please mute yourselves? So x bar NP plus 0.44 into 0.29 by 1.5. So this is your second Cm delta E equation. Now you use those two, equate the two Cm delta E's to find out x bar NP. So what do I do? This minus 0.29 by 1.5 x bar NP plus 0.44 into 0.29. Yes, did you have a question? Sanjeev, did you have a question? Let's proceed. So it's 1.5 equated to the first Cm delta E equation that we have seen. It's minus 0.19 by 4 x bar NP plus 0.32 by 4. अटेंड नहीं कर पाया, why? As in, I'm not sure what you mean by. All the videos are uploaded, all the videos are recorded and uploaded on the YouTube channel, and you have access to the videos and the slides. So to solve this, and we'll be able to find out x bar NP. In this case, I've got it around 0.479. So do verify if this is the right thing. This is what I've gotten. This is just one of the methods that I've followed. You can just solve 3 equations, 3 variables easily and find out x bar NP. You have only 3 unknowns, and the equation is same for all 4 quantities. Okay, let's go to the next question. Find the location of CG such that the aircraft has static margin of 5%. So static margin was what? We had x bar NP minus x bar CG. So static margin 5% means 0.05 is x bar NP we just found out to be 0.479 minus x bar CG. So x bar CG is 0.43429. Alright, so that is the right answer. Similarly, for a 10% margin, it's the same formula. So it's just static margin is x bar NP minus x bar CG. Static margin is 0.1. 0.479 minus x bar CG. So in this case, what will be the answer? X bar CG will be closest is 0.387, right? Yeah, so I think with that we're done with the questions of week 5. So we'll just go over some other questions now. So just look at this question. The aircraft total weight is 1245.75 kgs. The wing area is 17.075 meters square with center of gravity given as 0.3. And then you have the variation of pitch moment coefficient. This is Cm and this is Cl. Cm versus Cl. It has a negative slope like we have learned so far, and you have elevator deflection. So this is for each different elevator deflection. We had seen that elevator deflections do not change the slope of the graph, so the slope is constant throughout, only the y-intercepts keep changing. Alright, so this is for different elevator deflections, CM versus CL. Alright, so now let's look at the questions. First question is find the stick fixed neutral point, xnp by c bar. Just try doing this and then we'll solve it together. Stick fixed neutral point. Just a hint, so this is the formula that you should be using, static margin formula. You have CM versus CL, so you'll be able to find the slope. You have CG, x bar CG is given to you in the question as 0.3. You have to find out x bar n. So use the graph, find out the slope, and then find out the neutral point. Just try doing it. Just have to find the slope and then find the neutral point. Slope can be, you can take any of those lines that is convenient to you and find the slope, and any 2 points to find the slope. prior to finding the slope and prior to selecting the points about which, so points can be the beginning and the end of the graph, but before that you need to find the scale, the y scale and the x scale. So try doing that. start doing this. So first we find out the y scale. Alright, so y scale. So what do we do for that? You just take the first, so these are the first 5 divisions, so I'm just taking there. It's minus 0.15 minus of minus 0.2 by 5, so you get minus 0.01, not minus. So the y scale, so each division on the y-axis is 0.01, right? So now you find out the slope. I'm taking the last line, the pink line that corresponds to 5-degree down elevator deflection. So the pink line, I'm taking the 2 points, so this point and this point. Alright, so I need to find out minus dCm by dCl. So Cm2 minus Cm1 by Cl2 minus Cl1. There is a minus sign, so put that there. Cm2 is 0. 0 minus of 0 point. So it's at this point, so just calculate it using the y scale. So there are 2 divisions and it starts from minus 0.2. So you get minus 0.18 divided by Cl2 minus Cl1. Cl2 is again 0 minus of 1.2. This is straightforward, it's just 1.2. So when you do this, you get negative of the slope 0.15. And we just plug it into your main equation. So minus dCm upon dCl is 0.15 equals x bar np minus x bar cg. So x bar np minus x bar cg is 0.3. So x bar np would be 0.45, correct? So plus 0.445. Alright, next question. Most aft location of center of gravity will be? What will it be? So this is your fuselage reference line, this is your neutral point, and this is your CG. So most aft center of gravity location. I think we've done a similar question in one of the previous weeks. What will it be? So if your CG goes beyond your neutral point, it's not stable, right? So it is, the CG over here would not be stable, not stable. So the most aft location is the neutral point location, which is 0.45, correct? Alright. If a pilot wants to fly at a speed of 38.52 meter per second in trim condition, what will be the trim lift coefficient at sea level? They've asked you to find out CL trim. This is very straightforward. Just do this and we will solve it together. It's CL trim. Okay, is this better? Just a minute. Yeah, so what's this? Yeah. So let's just try and solve this. So we have lift equal to half rho v square SCL, and at trim you have lift equal to weight. So your CL trim will be 2W by rho v squared S. So you have 2 into 1245.75 into 9.81 by rho is 1.225, 38.52 square, or v squared S is 17. 5. Okay? So I'm getting 0.787 from this, plus 0.787, so that's what I've gotten. Okay, so yeah, this is the formula that we use to find out the basic lift formula. Okay, if a pilot wants to fly at a speed of 34.2 meter per second in trim condition, what will the elevator deflection in degrees be required to trim the aircraft at sea level? So it's a similar, first part is you need to find out CL trim, but note that your velocity value is different. So the first part is same, CL trim equals 2W by rho V squared S, where V has changed. You'll find out your CL trim and what is the delta E required to trim at the found CL trim. That is the question. Try doing this. CL trim is the same way, right? So you just have to do 2 into 45.75 into 9.81 by 1225. Your velocity is 34. So CL trim is in the same way, so I'm just plugging that in. Velocity is 34.2 squared. S is 17.075. I'm getting a value of around 0.999. And then you need to do delta E required. What was the delta E required formula? It was there in the assignment. So that's delta E naught, which is Cm naught by Cm delta E minus dCm by dCl by Cm delta E into CL trim. Now, CL trim you just found out, right? Try to find the others. You need to find delta E required. So using the graphs for each of the delta E required, you have 5 lines there. So try to plug in values and see which line it matches. So DCM upon DCL we have found out as 0.15, correct? So what we do here, instead of using the delta E required equation, is that you use a straight line equation. So slope we have, DCM upon DCL is 0.15, and you take 2 points, one is the y-intercept and one is the CL trim. So one point, point number 1 is y-intercept and point number 2 will be trim. So you take the values of CM and CL at that point. So slope is y2 minus y1 by x2 minus x1. So CM minus CM naught. Okay. So you have 0. That is a trim. CM minus CM naught by CL trim minus CM naught. So this is point number 1 is the trim and point number 2 is the y-intercept. Okay. So you have 0.15 equals minus CM naught by 0.999. So its CM naught value comes around 0.15. It's about 0.15. Now just look at your graphs and which angle corresponds to 0.15. CM naught 0.15 corresponds to which graph? I hope the graphs is visible. Yeah, so it should be visible now. So CM naught equals 0.15 corresponds to which graph? Just look at the CM naught values for all the graphs. Degrees down is magenta, right? This is what you said. This is 5 degrees down, right? I'm not sure. Is this the line you were referring to? Top one. Okay, yeah. Okay, the colors might not be clear. Correct. The top one, the red one, elevated deflection. 15 degrees up. Alright, so yeah, that is just, yeah, so that is how we here, so you have delta E is 15 degrees up. So 15 degrees up is positive or negative? According to our sign convention, elevated deflection up is positive or negative? This is negative, right? Deflection downward is positive. We just discussed this, so it's minus 15 degrees. Alright, so next question. So just take this. If suddenly the weight of 15 kg payload is dropped in flight and the pilot wants to fly at same speed of 34.2 in trim condition, the elevator deflection requirement as opposed to the previous case will be more, less, remain same, cannot say. So just you can just write the formula and see this, right? So CL trim is the same, correct? So CL trim will not be the same. So CL trim is 2W by rho v squared S, and W has reduced in weight. So you find out the new CL trim. So you have 2 into 1245.75 minus 15 into 9.81. Speed is the same, 1.225 this is 17.075. So you get the new CL trim and all other parameters remain same. So will your delta E required to be more or less? Just plug it into the formula and check it out. So same formula I'm going to use, the straight line equation slope dCl is, this is, we know this formula, we know this value is 0.15. 0.15. 0 minus C naught by the CL trim that you find out now minus 0. So according to this, what will the CM naught be? And then compare it to the lines on the graph and just tell me if it will be more or less. So what is the new CL trim? Comes around 0.987. There's only a slight difference because there's only 15 kgs dropped, right? And the new CM naught comes to 0.148. So this is 0.15, 0.148 will be somewhere here. So according to the data, do you think it will be increase in elevator deflection or decrease in elevator deflection? this is 15 degrees up, this is 10 degrees up, this is 5 degrees up, this is 0 degrees, and this is 5 degrees down. So if your CM naught is at this level, will it be more or less than 15 degrees up? It's less, right? It's clearly less. Let's go to the next set of questions. The pitching moment coefficient versus angle of attack for the large jet transport can be seen in the figure below. So they've given you CM and delta E values. Okay, the question is slightly misleading. So it's CM and delta E values are given to you, and they've given you the CL variation and CM variation with alpha. Okay, so and the XCG is also given to you. Now let's look at the questions. The elevator control power per degree will be. Just try doing this. Elevator control power is CM delta E, okay? CM delta E is good. We need to find out CM delta E. CM delta E, you have the CM and the delta E values, just CM1 minus CM2 by delta E1 minus delta E2. Just do that and let me know the value. stochastic fixed neutral point. We have the formula static margin, you can find it with that. Static. The slope can be the slope can be written as dCm by d alpha into 1 by dCl by d alpha. Right, so that is nothing but Cm alpha minus Cm alpha by Cl alpha. Then you have those two variations, then you can do it easily. So Cm alpha, Cl alpha is given to you directly in the question. You can find out the slope, and xCg is given to you in the question. You just have to find out x bar and p. Yes, that is the right answer. So I'll just write it down here. So we have minus 0.02 for Cm alpha. Comes from here. We have Cl alpha is 0.8. So it will be 0.08. Then you plug it in, you get x bar NPS 0.05. Next question. The zero angle elevator trim delta E naught in degrees. So delta E naught was, the formula is given by minus Cm naught by Cm delta E. Cm delta E we found out in the first question. Cm naught is given to you in the question directly. straightforward. So minus Cm naught. Cm naught is 0.03. Same delta A we found out in the first question, which is minus 0.015. This comes to 20 degrees. The aft center of gravity limit xcg will be the aftmost limit for Cg we just discussed will be the neutral point, right? So we already found out the neutral point as 0.5. So it will be the same. It's 0.5. So this was the last question for today. Tomorrow we'll look at the directional and natural stability and those questions. So does anybody have any doubts? If not, we can end the session today. We'll meet tomorrow with directional and lateral stability.